In this video, we'll get to know about different types of rainfall. Rainfall has been classified into three main types. Let's quickly get to know about each one of them. The first one is convectional rain. So here it's written conventional. Actually, it's not conventional, it's convectional. So there's a typo mistake. When you see the word convectional, does it remind you of the term convection currents? Convection currents is basically transfer of heat energy from one place to another. It takes place within gases, liquid, and even in molten rocks. You'll find convection currents in Earth's mantle where the heat of the magma is released upwards towards the lithosphere. Then convection currents are found in the atmosphere when sun heats the land surface, making the surrounding air warmer, and warm air rises and reaches troposphere, which is comparatively cooler. Now that you understand the meaning of the word convection, convectional rain occurs when the sun energy heats up the land surface. It also heats the surrounding air. And we know that warm air rises, and the rising of warm air forms convection currents because you see there's a transfer of heat energy. And naturally, when warm air rises higher in sky, it starts to lose heat, and that's how condensation takes place and clouds are formed. Once the clouds are formed, subsequently rainfall takes place. So if you see, it all starts with warming of air. For that, the ideal weather condition has to be during summer season. And the ideal location has to be equatorial region because we know that equatorial region receives sun rays all throughout the year. And if we go a little further, convectional rain is very common in the interior parts of the continent because land surface heats up faster than water surface. And the last line says it particularly takes place in the northern hemisphere. If you look at the world map, northern hemisphere has a lot more land than the southern hemisphere. As a result, the northern hemisphere heats up faster during its summer than the southern hemisphere during its summer. So this was all about the convectional rain. The next one is orographic rain. Now when you see the term orographic, you should immediately think of orogenic processes. If you remember class 11 chapter 6, geomorphic processes, in that we came across a topic called diastrophism. I have a video on diastrophism. If you want, you can check it out. I'll put the link in the description. Now within that topic, we saw this term called orogenic process, which is basically mountain building process. When crustal plates move horizontally, they either come closer or they move apart, or sometimes they slide past each other. And mountains are formed when two crustal plates come closer, in which one has to slide under the bigger plate, which makes the land surface to elevate, and that's how mountains are formed. So this is what is orogenic process. Now here it says orographic rain. That means the rainfall has to do something with mountains. The key element over here is the mountains. Now let me explain this orographic rain with an illustration. I want you to pay attention. It may get a little complicated, so I'll go in a step-by-step manner, try and understand accordingly. Alright, we know that both the land and water surface gets heated up due to solar energy. We will take the water surface because that's where evaporation is intense. So evaporation is basically rising of warm air that contains water vapor. When warm air rises, it does not rise in an absolute straight upward pattern because there are winds that flow horizontally, so somewhere the direction is a little sideways. Now the exact answer for this can be found in the laws of thermodynamics. So what the laws of thermodynamics tells us that heat moves from areas of higher temperature to areas of lower temperature. That means heat can move anywhere, up and down, sideways, depending on the situation. And the situation is the temperature difference. So temperature difference is really what drives heat to move in any given direction. Now we know that land surface heats up faster than water surface because land is opaque. Likewise, land loses heat faster than water. Now coming to the land surface, the top portion of a mountain will heat up faster and also lose heat faster than the valley floor. And that's what makes the mountains cool. Now the warm air of the ocean, when it rises due to evaporation, it moves towards the colder region. Now we know that troposphere is cold, but it's very high up in the sky, somewhere around 10 to 12 kilometers high. Before the warm air reaches the troposphere, at the mid-altitude, warm air gets attracted towards the colder region that exists at the top of a mountain. Of course, the warm air also gets a push from the horizontal moving wind. So overall, the warm air gets a push to move upward along the slope of mountain. Now warm air then starts to cool because atmospheric pressure decreases with altitude. As the warm air begins to cool, the water vapor present in it starts to condense. Clouds begins to form. Then rainfall occurs. As the air reaches the summit of the mountain, it begins to descend. While going up along the slope of a mountain, temperature falls, and while coming down, temperature rises. Automatically, the air's capacity to take in moisture increases because at warm temperature, air can take in more moisture. There will be no rain at this side of the mountain. This area is known as the rain shadow area. So basically, you see in orographic rain, warm air is forced to cool when it rises over relief features like a mountain or a hill. As the warm air rises along the slope of a mountain, it cools, condenses, and forms rain. This is what is orographic rain. And if I have to ask you where can you see orographic rain in Indian subcontinent, then you should immediately think of the mountains in Western Ghats. Because when the southwest monsoon arrives in Indian subcontinent, the monsoon winds have to face the hills and mountains of the Western Ghats. Likewise, Himalayan mountain range also blocks the monsoon winds. And at higher elevation of Himalayan range, it rains heavily. If you all remember the 2013 Uttarakhand disaster, wherein a sudden cloud burst event led to flash floods and landslides, that is a very good example of orographic rain. So I hope now you understand what is orographic rain. The next one is cyclonic rain. Here the rain is caused by cyclonic activity. And if you see what is a cyclone, it is basically a large scale of air mass that rotates around a low pressure zone. Because always remember, wind moves from high pressure to low pressure zone. So clearly here we are talking about two winds of different temperature. One has to be warm and the other has to be cold. Because high pressure and low pressure areas are formed due to temperature differences. Because we know that sun energy do not reach all parts of the Earth's surface equally. Now we also know that moisture exists in warm air and cold air is dry. The region where warm air and cold air meet, it is called a front. Like this, we have two fronts. One is warm front and the other is cold front. At the warm front, air rises, and at cold front, air sinks. So naturally, the light warm air will rise gently over the heavier cold air. And then we also know that troposphere has low temperature. That will reduce the temperature of the rising warm air. And the moisture present in it will start to condense. And that will lead to formation of clouds and thereafter rainfall. So basically, cyclonic rainfall is caused when two air masses of different temperature meet. Always remember, warm air and cool air do not mix, as they have different densities. As a result, when they collide, the warm air quickly rises over the cold air and starts losing heat. The moisture in it condenses to form clouds and then rain occurs. So this is how cyclonic rainfall occurs. So these were the different types of rainfall. I hope you found this video helpful. Thanks for watching and I'll see you in the next one.